Well, hello everybody, I'm back, and I certainly do want to solve problem 20 for you from the final exam study guide. This is a wonderful problem as it spans chapter 6 and chapter 8, and everybody can use more help with chapter 6. Now I'm hoping you have watched my video for problems 5 and 6 from chapter 6 because I'm going to use that same technique, which I think is superior for clearing fractions. Now this problem here says find all of x for which f of x is equal to g of x. Well, f of x is this, and g of x is this, and we want to know when they're equal. So that's all I did is I set them equal to each other down here. Now, as per that earlier video I mentioned, I gave myself space to work by creating these long fraction bars, and I parenthesized any binomials. So the 3 minus x becomes a quantity, and you'll see why I did that very shortly. Now, in effect, we're no longer dealing with functional notation. We're back in chapter 6. We have a rational equation. And one of the first things I want to do is note that x can never be equal to 0 here. So I'm going to go ahead and just make a little note. X is not equal to 0. It's possible when I solve this equation, the answer will be telling me that x is equal to 0, but I have to remember that x can never be 0, and I'd have to exclude that solution. So that being done, we're now free to clear fractions here. There's other ways to do this, of course, but I'm going to do it the way I did it for problems 5 and 6 because it's really the slickest technique. I call it wouldn't it be nice? And wouldn't it be nice if there was a 4 up here, a factor of 4? Because if there was, these 4's would cancel, and lo and behold, the fraction would be gone. And it would be nice if there was a 4 there, and it can be nice because we have an equation, and what we do to one side, we can do to the other side and not upset balance. So now we're free to go ahead and cancel here. Notice the 4's are cancel, the fraction is gone. I've cleared fractions to the left and nearly cleared fractions on the right hand side. Except I have this x in the denominator. Wouldn't it be nice if I had an x up here because then I could cancel that? And of course I can have an x up there. I just have to make sure I do to both sides. And so that's the technique, wouldn't it be nice? The x's cancel here. On the right hand side the fraction has collapsed, I just have 1. On the left hand side you can see why I parenthesize because we have to do this distribution. And the parentheses remind you to do that distribution. So when I do that I get 3x minus x squared is equal to 1. And lo and behold, we've gone from chapter 6 rational equation to a chapter 8 quadratic equation. Now I want to see if I can factor this home to solution. So I'm going to rewrite this. There's a lot of different ways to do this. I'll go descending power like this. I'll subtract 1 from both sides. And because I'm always cracking trinomials that are positive, have a positive x squared, I'm going to multiply both sides by -1, which is a sign changer, so all these signs are going to toggle. And we're going to get this on this side. And on this side, well, -1 times 0 is still 0. And so does this trinomial crack? I mean, can we simply jump to the solution like we did in an earlier chapter? And the answer is no, it doesn't crack. You can play with that a little bit, but you'll see it doesn't crack. And so we're left with having to use the quadratic formula or complete the square. I'm going to use the quadratic formula. The a is the coefficient in front of the x squared. The b is the coefficient in front of the x, in this case -3, and the c is the constant, in this case 1. So I rip out my a, b, and c. That's my first move. And then I backfill the quadratic formula. Now if you remember, the quadratic formula says x is equal to, and it says the opposite of b. Well, b is -3, and the opposite of -3 is 3. And then it was plus or minus, and the discriminant. And so the discriminant, what was that? That was b squared. Well, b is -3, and -3 squared is 9. And then it was 4 times a times c. Well, a and c are both 1, so that's very nice. And all of that is under 2a, and a is 1. And so now we simply crunch out that discriminant. And when we do, we get 9 minus 4, which is 5. Not a perfect square, and when you look at this thing, I'm hoping you're seeing that this is not going to simplify anymore. This is the answer. And you would look below to the multiple choices to see if there was this, or maybe perhaps this. Either one of those would be possible multiple choice answers. So there you go. I hope that helps. This is called the wouldn't it be nice technique. I'm convinced the best way to teach clearing fractions and the solution to rational equations. Go back and watch that video for 5 and 6 if you get a chance. And of course, good luck on the exam.